Did that count down for you then?
No, I can't see it.
Okay, that's fine. We are now live.
We're live.
We are now broadcasting live across the web. Not that anyone can see us. That's fine. I see what I did there. It's because I was streaming too early. So, hello, good morning. Indeed, here we are live in Studio 2 of the GGPHelp Studios. My name's Liam, and I'm your host for today, and I'm pleased to be presenting this live Brew with Bottle. And joining me is fan favourite and everyone's favourite civil engineer is Bamps. Bamps, good morning, sir. How are you?
Good morning, Liam. Good morning, everybody. I'm
That
fine.
microphone just might need another little tweak. I don't want you to eat it, but just a little.
How's that?
There you go. That's much, much better. Thank you. I'm going to turn myself down because I can hear myself just a bit too much. So we're here today live because we thought, having already done what three presentations now, Bamps,
Yeah.
that it's about time we, even though we've been threatening it since we did the first one, way back in, it must have been early September, with the guys in Stroud
Yeah, with you
at their
heckling me.
with me heckling you, that that. Sorry, my mum is now WhatsApping me now that I'm live. I mean, she'd had all day to talk to me, but now I'm live, she wants to send me messages. So yeah, we were at Stroud. I was heckling you, and we decided that we should really put this online for everybody to see. And so here we are. We've been noted. We now have a viewer at least. Hello, viewer. So let me just share my screen. And hopefully, Bams, you can see the presentation and stuff. So, what was it before we get into this properly? What was it that made you come up with the idea of a presentation,
What, this particular one?
or any of them? What was the
Um,
what made you
people
decide to do it?
people like to know they don't get the information from the Greatland website. So I'd like to go into more detail to explain things. And this one in particular, I was asked, where does gold come from? So this sparked my memory.
Okay.
My friend thinks I'm very brave to do this one because it's very deep.
Oh, but we like deep. 2 kilometers deep.
Three,
Let's
3 kilometers.
3 kilometers deep. There we go. So this is the first image, I believe. Is that right?
Yeah, now this is what they call an inflationary vacuum soup.
Okay.
Okay, now this is pre-Big Bang. Okay, so you've got all these vacuums floating around, and it's in a mix of electromagnetism, protons. No, not protons, photons. I always get those two mixed up. And these inflationary vacuums expand, and they keep expanding. And as they expand, the energy inside doubles, triples, and one of them popped, like putting a pin in a balloon. So if you go to the next slide, that's Big Bang on the left. So I'm talking about pre-Big Bang. So if you put a pin in a balloon, the air comes out one way.
Mhm.
Well, the energy, I'm talking about energy comes out one way. So that is what you're seeing, that is our universe. There could be hundreds of universes, as far as we know. This is very deep quantum physics, cosmology, Einstein's theory, and what we've got is a Big Bang, and just to the right of that you can see the afterglow. It's like a greenish, bluish That's an afterglow. And like if you turn a light on and then turn it off in the dark, you will see an afterglow, and it will dim. And after that, you'll get darkness. So just to the right of the afterglow is a cosmic darkness. Now, if you look at the bottom, you got that somebody's worked out 13.7 billion years. So we are on the right-hand side, on the last ring. That's where we are. So 13.7 billion years, and they're quite confident of that. But what the scientists don't know is what happened the millisecond after Big Bang. For some unknown reason, antimatter and matter should have cancelled each other out, and they didn't. We're left with a very small particle of matter. Now that matter isn't rocks or anything like that, it's energy, electromagnetism. And there's something called quarks, Q-U-A-R-K-S, and they come out of nowhere and disappear into nowhere. But according to Einstein, you can't have something come from nothing. It's got to come from something. And that something is dark energy. So when we go into the cosmic darkness, you've got energy. Now, this energy is, these quarks and the energy are forming atoms. You've got protons, neutrons in the nucleus of the atom, and the quarks are forming this nucleus. And we've got one electron in an atom, and that is hydrogen. So the first element that materialised from this Big Bang is hydrogen. The second one was helium, and these are the big gas clouds that you see on the Hubble satellite images. They're mainly hydrogen and helium, and in amongst that you get the stars forming with the heat. It's a bit like a cumulus cloud brewing up from the... When you see a big dark cumulus cloud, it expands, and the energy inside it is enormous, and then you get thunderbolts coming out of it. But it's a bit like that, but this is different in the fact that it's every time there's an explosion, you get different minerals forming. So the heat, the energy, is affecting the electrons in the atoms, and the atoms are changing, and they're forming different elements. Now, they've formed different elements up to the iron stage. So when you get to iron, the stars start forming, and that is probably about a third of the way along. There's some bright lights on that left. So
In there.
These stars start forming, and eventually they will turn into a supernova, and they will explode. Okay, so then you get further metals forming, further elements forming in those explosions, and they're all shooting off. All the energy is going outwards, away from Big Bang. So all these rocks and iron elements are moving towards the right. And eventually what you get, you go through the likes of the cobalt, nickel, silver, and then gold. Gold can only come from the hottest supernovas. Okay, people have tried to make gold on the planet here, but it needs tremendous amount of atomic energy to split the atoms to form gold, and it just wouldn't work properly. But all the gold that we're digging out comes from one of these huge supernovas.
Well, I never.
So I'll don't know whether I've gone too deep.
I've learned something there. I think that's awesome.
I've lost you. But one thing about this is, each element has a different colour in the spectrum. Okay, so when this Hubble telescope, or whatever it is now that's up there, there's a new one taking great pictures. They turn on the infrared or the ultraviolet, whatever it is, and they can see different colours of the stars. So these different colours tell you which element it's in. So they can pick out iron, pick out gold. Well, probably not gold because you can see that, but you can see different elements and different stages of their evolution. We can see backwards in time because that's what we're looking at. We're on that last ring, so we're looking at everything that happened in the past. By the time the light gets to us, that is gone. But there's nothing out in the future. It hasn't happened yet. So we can't see it. But we can see everything we look at with the stars is in the past. So we can see all these explosions. And this new telescope that's up there it takes away all the blur and looks deeper behind the closest stars and looks deeper backwards in time. So they're quite confident that this is how things happened, but they don't know what happened the split second after Big Bang. Okay, now gold came about, I would say about 6 to 8 billion years ago. No, 6 to 8 billion years on this timeline. The Earth started forming 4.5 billion years ago, so that's it, 9 million. So the gold came about 2 to 3 billion years before the Earth was formed.
That's just blown my mind.
So that has travelled 3 billion years to get to Earth, and it spread all around the rest of the universe, but it's the bit that we've got took 3 billion years to get to us, and that was 4.5 billion years ago. So we'd like just flip through another couple of slides. The different ideas from people. You can see the galaxies forming before it gets to us at the end on the right, and all the dust clouds in the middle. That's where all the elements are forming, and then the supernovas are in that. So that's where the end of that lightish blue is where the gold was formed. You can flip again. That is the afterglow, a map of the afterglow. Fascinating. Okay, flip again.
Wow.
That's our universe with infinite edges. We don't know how big the edges are, but it's going faster. It shouldn't be going faster, but it's going faster. And they're presuming it's dark energy. The dark energy dark energy is keeping all the galaxies and all the cosmos together. And the dark energy is pushing everything out faster. So as we get further out, it goes faster. But if you took that scale of that particular picture, the end of the universe would probably be twice around the planet. So, I mean, it's mind-boggling sums.
Yeah.
That's 13.7 billion years. It's going to be trillions and trillions and trillions of years before the end of the universe. And the end of the universe will probably end up as a soup of inflationary vacuums.
Easy for you to say.
Look, this is just stuff I've been picking up and reading. So if I get anything wrong, don't come back to me.
No, of course not. Of course not. Should we go for the next one?
Yep. Hadean period. This is where the Earth is forming. Okay, so there won't, as it's forming, there won't be those lumps going around, those meteors. They'll be iron based. Okay, so there's iron coming into the Earth. So if you go to the next one, I hope this one comes out. Oh yeah, come back. Hadean's right at the top. Okay, and then the Moon joined. Now there's still a debate how the Moon and the Earth came together, but the Moon was very close or joined to the Earth, and over the 4.5 billion years it's been moving away from the Earth to where it is now, and it's still moving a couple of centimetres a year away. Okay, so that's the Hadean period. That's where most of the volcanoes. What's happening is the iron is being drawn down into the core. Okay, because the core is iron. What on its way down, 200 billion years after the Earth was being formed, the gold arrived on other meteors. Okay, so gold and other elements came to Earth, and the iron drawing everything down into the core, so that the iron is drawing gold, silver, whatever, into the mantle, probably the upper mantle. Maybe, there might be more down, I don't know. Okay, so that's what's happening in the Hadean period. The next period down is the Archean period. Okay, now this is quite important for Ernest Giles, because this is where our greenstone period is. Okay, this is where gold is, but other metals haven't formed in that rock.
So just so I can get this in my head, because this is all coming from inside the Earth, but the gold is, it's not gone into the Earth, is it? It's already there, but as part of that explosion, it's part of that bubbling mass of gas and lava and everything else, right?
Yeah, in the Hadean period, the Earth started 4.5 billion years ago, and the gold came at 4.3 billion years ago. So there's a gap in the formation of the Earth, and then meteors brought the gold in. As it hit this red giant, it sucked all the metals downwards into the ground. Okay, so by the time you get to the Hadean period, there's rocks forming, and the greenstone, they call it the greenstone belt. Right?
Yeah.
They're old rocks. Okay, they're not like Britain's sort of like a lot of sedimentary, but some of the rocks in Scotland and everything, and the Malverns, they're all about 600 million years ago.
Oh, they're young, aren't they? Really, at that.
Yeah, when gold miners are looking for gold, they're looking for Archean rocks. Okay, so they're looking for this 3.5 billion years ago. I think if you, I don't know, you can't blow that up, can you? Those dates on the right. So
How's that?
Archean period. Okay, now near the end of the Archean period, see that you've got the algae. See those little green blobs? That's algae. And the blue-green stuff you see on water sometimes.
Mm.
Okay, now that is the first life that we've got in the Archean period, and they start to produce oxygen. Okay, so there was no oxygen before that time, and this oxygen just exploded into, there's just loads of it from this algae. Okay, so what you got to think about oxygen, it sticks to other minerals, copper oxides, iron oxides, there was no oxides before this date, so there wasn't any rust.
Sounds blissful.
So the oxygen is needed to join up to all these other, like carbon dioxide, nitrous oxide. They're all oxides joined with something else. Okay, now with oxygen it also joins with hydrogen, and there's a lot of hydrogen on the planet. So we've got water, so water started forming. And then you go down into the Proterozoic, which is lower down. Now that white ball, they call the snowball Earth. Now that is from 650 million years ago to 600 million years ago. Now Havron was formed around 630 million years ago. So Havron formation would have been in amongst that snowball Earth. So when those glaciers started melting, that's what formed our cover sequence on top of Havron.
Okay.
Now, there's a lot of the tillites. The tillites are all glacial deposits. You can see that the dinosaurs and man and everything else and all the vegetation came way down. So there was a lot of time for this formation of Havron to take place over time. Okay, do you want to go to the next slide? Is that all right?
That's brilliant. I'm loving it.
Because you can, I don't want to talk over people's heads. Probably I've lost a few people already. There's a few blank looks at Stroud anyway. Nobody fell asleep. So
there we
this
go.
one here on the left, the centre of the core, you can see is iron, molten iron. And heat draws minerals towards it, so you will get minerals being drawn down. So in the upper mantle, the upper mantle is where we're looking at. Right, between the upper mantle and the lower mantle. Right, the upper mantle moves, and it's called tectonic plate movement.
Yeah.
And the tectonic plate moves over the lower mantle and causes friction and causes heat. And that heat will come out as magma through cracks. So if we can go on to the next slide. There's not many maps around it that time. This is right, this is 650 million years ago. It's not a very clear map. The quality on the website wasn't very clear, but you can just about see Australia above the equator.
I see it here.
Now that dark greenish brown bit is the only bit of Earth that was not covered in snowball. Okay, and look where it is.
So if that's Australia, so
Western Australia.
Western Australia, because that'd be Perth over there, wouldn't it?
Into northern China, look.
Yeah.
Not South China, because North South China wasn't attached to Australia, but North China was, Mongolia.
Oh, South China's up here. I see it.
Yeah. So you got India should be to the right, to the left. So there's a bit of India with that, but there's also Antarctica's got this in, and South Africa, which is down the bottom. Now in South Africa, so you got the. So this is all Archean rocks.
So essentially, Archean rocks that that say are in Australia and then are also found in North China were at some point all together on the planet.
Yeah.
Right, makes sense.
So this was 650 million years ago. You got Scandinavia down the bottom, Laurentian and all that, but that gradually that moves up and around. Look, you got West Africa down where Antarctica is now.
Yeah.
Fascinating that is, but that, as you go through into 600 million years and 500 million years, you've got Gondwana land and appearing. I think the other one is Rodinia. I think it's one of the other ones. So, and they're all moving all the time. So when Australia and South China, North China, split, you got great tension where they split. Now you can see that in the Pacific and the Atlantic, right in the middle. You got the North Atlantic region, the Pacific ridge, and you've got the Hawaiian volcanoes. You've got all the volcanoes in Iceland. It's where the magma can get out.
Mm.
So as it's pulling away, it's causing heat, and the heat comes up in magma through these faults. So in Australia, we've got the plates pulling apart, but it's also moving in other directions, causing pressure on other places. So you get volcanoes due to pressure. And if you looked at California and Canada along the Rockies, that is pressure from the Pacific plate moving towards the North American plate. So there's all different ways that the tectonic plate movement was giving us magma. It's one of the main causes of the magma. I don't know if you can flip over another one. So this is just a general view, but you've got the magma down the bottom, and it follows a weakness up. And it may go vertically, or it can go horizontally through a weak joint called a sill, or it can go diagonally, a dike. But ours is more, Havron is more like that one on the left in dark grey. Go to the left, that's it there. So similar sort of thing with breccia. What happens is the rocks are heating up, and being rocks, if you heat them, they crackle. Okay, but if the molten magma hits them, they'll melt. But these aren't the ones we've got Havron at the top, are crackle breccia, and they've just cracked. What it's done is form a weakness, so that the next intrusion coming up will force its way into the cracks and leave behind quartz and gold in the cracks, and that is called cemented breccia. And then you may get another one with actinoids come in. Now this is bringing other metals in. And if you look on the periodic table, which I haven't put on these slides, you will see that there's a layer down the bottom called actinoids, and you've got uranium and stuff like this in it. So these actinoids have given us actinian breccia, and this has got asbestos in it. That's it right down the bottom. Should the green in U. See
The U.
All those green ones are actinoids. So we could have any of those in this actinoid breccia that we've got. And I think it's a confusing way they they've put all this together. It's very clever. But the shells, see the hydrogen in the top left and the helium at the other end. They've got one shell. So you've got a nucleus and one shell. So as you go down, you get 2 shells and 3 shells, 4 shells. But when you get down to gold, which is in the blues,
Took me a while.
I can't see that, it's too small for me, but it's 79 protons.
Yep.
79 neutrons and 100 and some electrons. I can't remember, I think it was about 112. But they're in different rings. So there's 6 on gold. There's 6 rings, and you've got 1 electron in the last ring, but then there's 11 electrons in the second ring. So the way I think it's been organised to the right is by it's electro resistance, I think it is. I may have gotten that wrong. But it weakens as it goes further to the left, or increases. I think that the storage capability of electricity is to the left, and then that decreases. So the conductivity and resistivity is in different directions.
Okay.
Okay, but going back to these actinoid brachias, it's full of elements. There could be a lot of elements in it, and that's the only place I can see where the nickel could be. So I think we've had 3 sorts of intrusions. Now, when I'm talking about intrusions, if you think of a lava lamp, we used to call them in the 60s and 70s astro lamps.
Okay.
The fad thing that if you look at an astro lamp, you put there's a bulb at the bottom, you turn the electric on, and the bulb is warming up, and this wax inside this liquid, you can see it start to expand and move. That's them. And they come up in blobs. So the longer you leave that bulb on, the hotter the liquid, the faster they will move, and the more pressures they will insert. So what I'm trying to say is the first intrusion may have not been that hot to get through the rocks. It's found a weakness to get through, and it's cracked the rocks to form crackle breccia, and then the next intrusion is slightly hotter, and it's got further in, and it's forced gold in and quartz into the cracks, and forced with the heat, it's forced more of the rocks to crack, and they keep cracking and keep cracking. But I don't think it got to the surface. But the surface would have been covered in a glacier. Now, I can remember Magic Trade saying that there was no glaciers at this point, but I think there is. I think there was, especially with all the tillite, because the tillite is a glacial deposit.
So at some point there was.
Yeah, but that is a great picture of what our intrusion happens with our intrusions. And I think the last one was the sulfide intrusion. I think they're all coming up from the fault line under the eastern breccia. I think they're all coming up through that way. But the sulfide is the only one that breached the surface, and it was probably hot enough to melt anything if there was ice above it. And I think we may have lost, I can show you on one of the other slides in a minute, we may have lost some of the sulfides to erosion. But I don't think we've lost the breccia, because the crackle breccia at the top is still quite evident. So I don't think we've lost any of the breccia to erosion.
Oh,
There's a video on YouTube, 4 hours 23 minutes watching a lava lamp.
oh, superb.
Who needs a TV?
It's just...
This is yours, isn't it?
It is mine, yeah, sorry. Just so people can see that that when I come back, and then we're going to go to that one. Next slide.
Okay, next slide.
Uh-oh. I've got to zoom out. Then it'll go over. There you go.
Yeah, this is a picture of Telfer. Well, before they dug it all out. And I don't know if you can see that little blob bottom underneath Telfer. There. And there's a dimension above it, 1 kilometre. Is it 1 kilometre? It is, isn't it?
Yeah, yeah.
So you can imagine how deep that blob is from the top. So it's got to be 3 kilometres, isn't it? But the gold would appear around the edges of that, not actually in that magma at the bottom. The heat is drawing the elements towards it. So anything that's in the surrounding soils, the heat is drawing the elements in towards it. And each element has a fluid state. So each element is going to be fluid in a different point, at a different heat. So, like tin will flow first. It will flow miles away. Copper flows. And nickel has I think it's a lower fluid state than copper. And it's also sulfide states. The heat and the cooling, it all adds up to where you're going to find copper, nickel, gold. And those red lines are reefs. The top ones at the top. I believe that in Telfer they found 6 reefs. And I'm hoping that's what they're going to find at Black Hills. It's like a layer of the stratigraphy has been taken over by the magma and left the minerals in the stratigraphy in layers.
So it's almost like if the tide came in, went over the rocks into a pool, the tide goes out, and what's left is a rock pool, basically.
Yeah.
But you're saying that that's left minerals behind in that little rock pool.
Yeah. It's cooling and the different temperatures of the magma, and then the cooling, the fluid state of the minerals. And there are tables where you can find out what fluid temperatures these metals will flow at. Okay, next one.
Loving it. Oh, there she is.
This is hydrogen's, not mine. But I grouped it. That's where I've moved. That's what's happened. That yellow is the old 650 by 350, but even that is increased. That yellow line that you can see. And the purple line, all those purple arrows are going out to the boundary of the alteration. So over the last couple of years, that alteration line has been getting bigger and bigger and bigger. So, and I still think it's going to go the way he's got those arrows. I'm still convinced to the northwest it will go underneath the Havron Lake. I'm convinced of that.
I've probably got too many here. I was just going to try and highlight the lake for everybody while you were talking about it. Keep going.
Yeah, well, it's to the top left of Havron. There it is. That bit. So I'm convinced it will go out that way. Yeah, that's the northwest pod, that circle. So that's grown, and
There you go. That's much better.
yeah. So you can see where it's moved. The northern corridor is moving sort of to the right of the pod. And when you look back at the, I think it was the PFS, might have been the MRE, there was a showing the shells. There's this loop with a blank end, and it's looking straight towards Avalon Lake. I don't think you'll find that one, but
No, I haven't got that one.
I should have put that one.
Okay, back to you. Back to your image.
That's Callum's cock and balls. Oops.
It is actually.
Yeah, so you can see these dotted purple lines. They're what they're trying to fill in at the moment. So they've got one at the north end of the eastern breccia. You've got the northern corridor. You've got the gap between the pod and the corridor. They're trying to infill that, and they're still heading for the eastern breccia, and also down in the bottom right. Now that bit that sticks out at the bottom, I think that's where the intrusions are coming from. I think that purple sulphide is going to keep going down to the right. So we may not see any information come through on that until we can get drilling underground. It's too deep.
Yeah.
Too deep. But the drilling at the moment is going to be focusing on the mining plan and how they're going to synchronise the slosh plan with the bulk caving plan. So that is what I can see going on at the minute, is planning. I think that's what's delayed the feasibility study. I don't think they've got enough information yet to actually be able to separate the two.
Right. Okay.
There's too much. They were under the impression everything was separate. The eastern breccias was separate. But the last few months, they've been leaking all the high grade stuff up. It's all linking. And I think it's all coming from the same intrusion from the bottom right and coming up. That's only my opinion. Could be totally wrong. Magic would probably turn me off the strip for a few things.
Oh well.
Next one.
Next slide. Hang on.
But that,
There you
by the
go.
way, is far bigger than my calculations on my lower ovoid theory. It's way bigger. I haven't calculated anything since. I'm waiting for more information.
Fair play.
Yeah, now this one, how old do you reckon that is?
How old? It's in the image or the actual what we're looking at?
Yeah, the image.
Well, there's no eastern.
I got that off the September one.
Because that's a new one.
It's a fairly new one, but not a new one.
Okay.
If you go back to the other one, That's 3 months. It's just the last 3 months it's changed dramatically.
Hmm.
I advise anybody to look through those RNSs and have a look at these 3D images and just see how quickly it's grown in the last 6 months. It's just super, just fantastic speed. Okay, next one. Now this is a really old image, about 2 years old. That shows the crescent. Okay, but it shows. You can see what I mean about spectrum, right? That when I was going on about the cosmos and the galaxies and the Hubble telescope looking, and they look at different colours in outer space. Different planets, they're all different colours. Well, the same happens when they're doing the electromagnetic surveys and the gravity surveys. You get images of colours. They're not actually hills or dips, or they're images of what's in those rocks. So here you can see an electromagnetic survey, and it's picked up. That's Lake Havron. They've picked up similar readings. That's in the crescent. That's why I'm thinking Lake Havron is involved.
Hmm.
That's a good one. Next one.
I mean, is it possible that Lake Havron was actually a volcano at some point?
No, I just think it was a system of intrusions,
Okay.
like a lava lamp.
Right. Got you.
There was umpteen number of intrusions, like a lava lamp going up and down. Now, magma can come up like a lava lamp. It can come up like a blob in a synaticoids. Probably said that wrong. I always do that. But it can also come down if it's in a sill, horizontal sill, and it finds a weakness. The magma would come down and be called a granitoid.
Okay.
It's another bit of useful information out of my head. Next one. Yeah, that yellow line, that's where they're drilling from at the moment. Okay, now I reckon they're drilling right down to the bottom, right. So into the southeast crescent, through the southeast crescent, and they've gone into the link. That is my view. We should be getting this, or we may get it on December the 8th, is it? The 9th?
Mm-hmm.
Well, we got to look at this, because it's so deep. They don't want to just go, they don't want to come from the southeast down, because it would be going through barren rock all the time. So what they're doing, they're coming out past Lake Havron, and they're picking up the northwest pod, the northern corridor, the southeast crescent, and the link. So that they're utilising a drill to hit three or four resources, and the link zone as well underneath the southeast crescent. They're trying to fill that in as well. So that's a deep drill, that's a long drill. But this Mitchell seem to have got a deep drilling method now. But I still don't think they'll get past 2,000 metres, and that is getting near its maximum.
Crazy.
Yeah, I just think that is 1,650 metres to get to the link zone. But it may go deeper. I still think there's an extension down to the southeast. So it's going to hit the northwest part, the northern corridor, southeast crescent and the link.
Wow.
So, yeah. So this is a section. Now, the section is marked on the plan as S2. I think this one is. And the blue lines that you see coming down, they're what we're expecting on December the 8th. Well, hopefully we'll get them. The deep drills, so they may even take longer. You have to imagine that these deep drills, they could take 3 months to get down to the bottom.
Mm.
And they're having to pull cores out every 4 to 6 metres. So there's a lot time-consuming effort to get the cores out from down the bottom. And all the cores are down the bottom. So we've got that round bit at the bottom. See where the section sort of finishes and it's round. This is probably from the aero survey. As the aero survey flies past, the images are weak down the bottom, and the reflections of the images don't hit the bottom properly. So they're hitting the sides, but they're not hitting the bottom properly. So you get a round image. Callum tried to explain that to me, and he lost me a bit.
No, that kind of makes sense. So, because the fact they're firing a signal through 2 kilometers of rock, effectively, anything after that, and it kind of starts getting a bit of a fuzzy signal.
Yeah. They may be picking up from the survey tools that they stick down the drills as well. They probably are down at that depth. But if you look on the bottom right, the depth, right on the edge, there, that is 1350 from the top to the bottom of the ore. But there's another intercept below that. Can you see that?
156, 30 meters, 1.5 grams per ton.
Yeah, so it's still going down. This is a very thin image. It doesn't really show you the true scale of it.
No.
Those blue lines are bringing the eastern breccia out. That blob on the right is the eastern breccia, and you can see the diagonal nature of the dike.
Yeah.
Which is what I'm trying to explain. From the top layer of ore to that 1350, 1400 deep is about 300 meters to the east. And that dike is aiming towards the fault. So that if there is any mineralisation, it should be following that dike down, or the dike is following the mineralisation down. And it also shows on this one the sulfides finishing. Can you see that? The purple seems to loop round and finish. Well, that can't start from there and go up. That's got to come from down the bottom.
But we've just not been down deep enough to find it.
They haven't found it yet. They haven't found a link yet. They've got time. I'm thinking that will tail round and follow that dike down, that sulfide.
Fill in this nice little area here that doesn't have anything in it.
Yeah, it may come up in blobs and then go through a bit and then in thin layer and then thicken out again. I don't know, let's hope it's there. stuff. Next one.
Wow, look at that.
Yeah, this is before. This is with a gap zone. So you got the eastern breccia and you got the deeps. But the latest drilling has filled all that in.
Hmm.
So the purple and the deeps will be slosh mined to about 1350 deep. And the eastern breccia is joined up with it. So what I'm trying to say is that the drilling is trying to devise a plan, give information to devise a plan for the bulk mining to occur in relation to the slosh. And they will both be at 1350 level, because a bulk mine has a minimum height it can cater for. So if we're looking at 1350 deep, the eastern breccia starts at about 800, so we've got about 550, 600 metres depth of eastern breccia. Now the new method that Newcrest has developed and patented, I think it can go to 800 metres, but 1350 seems to be a logical level to get the bulk mining out, because then you could have a crusher down below that to serve the bottom of the slosh and that bulk caving, and then from the crusher it would go down onto conveyor and then a conveyor out. You couldn't truck that distance. You're looking at 9 kilometres to the top of that wall. Well, I don't think you could do it. There are firms that are trucking it out, but the cost to be too much, I think.
It'd certainly be more efficient, wouldn't it, to crush it and pop it on a conveyor and send it on its merry way.
Yeah. You've got to crush it at some point, because when you dig out ore, when it blows up, it's all different sizes.
Hmm.
And when you pick it up in a bucket and you put it into a lorry, it's got a bulking factor, and every time you touch it, there's more air gets in it, and you get a bulking factor. So it's 3 times when you first move it, and it's probably twice as much again when you put it into a lorry. So by the time you physically loaded that lorry up, you've got less tonnage in the lorry because of the bulking factor.
That makes sense. So it's almost like your French drains when you throw stones down to help the water get through, because of all that space.
Yeah.
Yeah.
Yeah, so what I'm saying is you need a crusher underground, really, to stop the bulking factor, so you get a primary crusher.
Mm.
And the crushing, the underground crushers are quite extensive, quite big. There's normally a great big cavern, and then they crush it and it goes down onto the conveyor, so the conveyor will be even lower.
And that's why, even if they reach the top of the ore body, let's say April to June, it's still going to take them about a year before they can start developing stuff, because they've got to still put all that infrastructure in place.
Yeah, now that's why I think they're going to go for the 300mm top, the top of the sulphide, and the northern corridor and the pod. I think they're going to change the plan round from being a long, deep one into a shallower, long one. Does that make sense?
I think so.
So the top 300 metres over the whole of the oval could be sloshed. It's going to be cheaper to get it out from that top 300. The grade average will come down,
Mm-hmm.
but it's going to be cheaper to get it out, basically. And in that time, they could be getting a conveyor down to the bottom at that point, while they're doing that.
Yeah.
That's my opinion. But who am I? Next one. People keep asking me plans and sections, and people get confused what's happening, really. But these have been taken off different RNSs, and they've layered them in the slices, so you can actually see the ore as it's going down, and you can see the crescent being a full crescent on the top, and the northern starts to retreat, and you can see the northern coming right down, so that you've just got like a hockey stick at the bottom. Next one.
There she is.
That's a great shot. Great shot. So you can see all those ridges, those dark lines. You can see that that's the movement in the shifts where they excavate, and then they spray it. Great shot. And he's using an electronic theodolite, geodometer, to line the tunnel. So that gives it its position, its level.
And it's that's the rock face right in front of them, is it? That, or has that got anything on it, or would you say that's actually the rock?
No, that's the rocks, isn't it? That's ready for marking out and drilling the next one.
Right. Okay. Very cool.
Now on the jumbo they got on the name of the jumbo it's got a little eye by it, and that means it's computerized. So he would be just checking that it's in the right place. The jumbo would be computerized, so the arms you wouldn't have to mark. The old days they'd have to put a cross where the jumbo drills. But because this is a computerized jumbo, the jumbo arm would be drilling with the computer aid. Okay, next one.
Yeah, I was just going to show you a quick image of a jumbo. Hang on. There you go.
Yeah. So the old method would be to drill across. Now they've actually, I don't know, can't tell whether they've marked it or not. Look, there's some lines on it. I know when we first started, we had a jumbo that, see that little eye, 923i?
Yeah.
I think the jumbo that we started with didn't have that eye. It wasn't computerized. But that's a monster, isn't it?
It's huge, considering there's a bloke sat in the cab.
Yeah, he's doing the horizontal to the sides, horizontal rock bolts. Is there 4 arms? There isn't. There's 4 arms. The one at the top.
No, there are. I think
could be going upwards.
they.
Great tool, anyway.
Yeah, I'm now looking at pictures of jumbos on my other screen. I mean, look at all these. What's not to like about these? Anyway, I digress. Oh, that's torn it. I've broken my presentation now.
Oh no. Wasn't a lot left.
Oh, there we go.
Yeah, now, this is looking from down below up. And I've tried to pick out the decline that starts from the top of the ore and going down to the bottom of the southeast crescent. Okay, so there's some yellow lines on the right where I've put decline. So our exploration decline is coming down from the top, and it's coming down, and it's coming down the blue line from the centre at the top, down in. That one, that's it. And if you follow that down, you can see the western front drive. Okay, and then you can see the slosh drives going off it into the ore. Now, from the top of that, the decline turns right, and it starts going down this spiral. So, I've put western front first level. You can see that first drive coming off the spiral. That's about 500 meters from where it turns right. So we've got 500 meters more decline to do before it gets to the western front first level. It's a bit of a jumbled mess, that one.
Yeah, I think I see it though. Which I mean, I guess once they fork off and turn, they can actually start a second mine in front, can't they?
Well, I think there's going to be maybe 4 rigs, 4 gangs. When we leave the bottom spiral of the exploration decline, there's room for more gangs. And I don't know if I've got another one to... Is there another one on that?
Let's see. Oh, look at that! Stunning.
Yeah, so you can see where it turns right there. That's it. So it turns right and it comes down the first bend and comes round, and then that goes off into the top, into the ore. If you look at the purple on the top, if you see the purple sulfides, you've got these tunnels going through it. Okay, so there's a 30 metre step up in the sulfides, and that's what we're going to hit first. So you can see where it turns right. You got that drive coming down, and it hits the ore. So I think while this spiral was being constructed, there'll be another rig, and it will start going down towards that ore. I think that ore there will be the sample ore. They'll need samples at Telford, so I think they'll be getting that out first. But that's going to carry on through into the northern section, and I think this is where they're going to start fan drilling. So that should be fun.
What's fan drilling?
You need to look at Bruce Jack Mine, and there's some fantastic images. So you're too quick on your result nights. You scan past Bruce Jack straight to Everett.
Guilty as charged.
If you look at Bruce Jack results, they're from fan drilling.
Right, okay.
And there's hundreds of meters of fan drilling. And it's where they, from one spot, they'll drill out like a fan. Could go horizontally, downwards, upwards. Okay, so they're not tied like they are on the surface. They've got to go down. They can go horizontally, upwards, downwards, or whatever, diagonally. And they can pick out. They're going through all the time. So we've got no waste drilling. So it's very economical to do fan drilling rather than drilling through 400 meters of cover. So we should get more results eventually.
Like that.
Yes, that's it. You can see that loads of it. So eventually we'll get far more drilling results come through again, like we used to, be like the old days.
Because I guess, and this has just kind of hit me, once you're underground, you no longer only have to drill downwards,
Now you can drill horizontally upwards.
whatever way you like.
Yeah.
Wow. All right, I didn't even think of that.
But the rigs are going to be smaller. You're not going to get these big, gigantic rigs.
No,
They
because
do
it's
2,000. They only need to drill 100, 200 meters, something like that.
yeah.
But they can keep going down different layers. I mean, on that one you can see they've come down the spiral at different levels in the fan drill. So they've got a greater knowledge of the ore body for the mining plan. Yeah, that's good, isn't it?
Yeah, it's pretty impressive actually. That's crazy.
There's three. You can see three blue lines coming top left, coming down through. Right, they're coming from the vents. There's three vents that are going to go in.
Hmm.
And the bottom right hand side of those three will go over the dike and then go down. There's three vents, so there's a lot of vents to go in, but there's room there for three gangs. And besides the decline, which is the next one down, there's two more below that with other little ones joining them up. Now they're both from vents, but the bottom one is linked to the fourth, or you can get to the fourth spiral on the left. Okay, now that one comes down and we'll get to the first level slosh mining probably before the decline gets there. So you've got room for about 5 gangs there, if they want to go that fast. And they probably will do. What you have to do before you can get anything out, production ore, is to make it safe. It needs to be approved by the government that it's safe. They will send a health and safety exec down to inspect. So all the vent shafts, they've got to be working. There's a lot of obnoxious gases when you mine. Sulfur. Because it's volcanic, sulfur will always come out of the rocks when you're breaking them, blowing them up. But you could get asbestos and arsenic, all of the sort of radon gases. So they need to be extractable before they start mining. But if we only do the top 300, the infrastructure is a lot less.
So less costs.
Less cost. But if they did the top 300, they can get a 3 million ton plan out of the top 300. And then they can have a second phase slosh going down deeper. So in this mining plan, we may get 6 million tons put in 2 separate layers. But we won't get 6 million ton out altogether until they put a conveyor in, or a hoist.
Yeah.
So I'm hoping that they'll put a hoist in. Okay, go ahead, next.
Yep.
Yeah, there I've just picked out the decline where it turns right, and I've circled the intersection where the ore will be coming out. So that's quite a long way, that 500 metres. So it's going to put another month on the decline. Excavations.
This one?
Yeah, this is new licenses. This is your realm, isn't it?
Yes.
We've picked up Citadel. Well, we haven't picked out where Citadel Hill is. We're in with Fortescue for that one. And Fortescue seem to be picking up licenses.
Oh, hey, Callum.
Go away, Callum.
Not now. We're busy. Here we go. I don't know if we've got it in there now. I've done this. That's a pending. That's a pending. Oh, I see. There's those ones.
That's one.
I'll just go back to yours.
One.
Yes. Now, we actually did some work on that.
Yeah.
Let's go back to it because I found it and I was trying to show somebody else. And I ended up sticking it in the wrong box, which is why I lost it.
Yeah,
Not Patterson.
I'm quite interested in that one because that top left of Black Hills was where we found all the historical drill readings. You remember?
Yes. Up here.
Something like 8 meters at 4 grams per ton or something. But that geological trend goes northwest through Antipas and then on into Wanman.
So we actually, there we go, translated a load of old drill holes. So we've got this whole area that's, there's another one somewhere that will just make this go crazy. My Google Earth is really not as logically laid out as Paddy's is. Paddy's is so well maintained. No, I'm not going to find it, so I shall save wasting any of your time.
The historical drills, some of them are quite weak, but they're consistently all over the Black Hills.
Mm.
There's one that's to the right of where they've been drilling at the minute.
There it is. It's in there somewhere. So these are all the converted drill holes.
Hang on, if I can describe, I can't see the number. Where your arrow is.
Yep.
No, to the right, up a bit. No, down a bit. To the left. Somewhere there, one of them. It's 63 meters at 0.17. So, don't understand why they're not drilling around here.
No.
Never mind. But that was the best one I found. The longest intercept. But right in the top left-hand corner, it seemed to have quite consistent 4 meters deep, 8 meters deep, sort of ranging anything from 1 to 4 grams, as far as I can remember, on the top left corner there. But they go across. Those historical drills aren't confined to Black Hills. They go off.
Oh, you can see them here.
Yeah. But that is wildcat drilling. Those are
Yeah.
things.
There's a bunch here as well.
Fundamental, researching the geology or anything. It's just wildcat to find target areas. But all they kept finding was similar intercepts.
Do you think that's because they just never went deep enough and so they never got the full story?
No, I don't know. Not around there anyway. Maybe. It depends where BHDO001 is. They've gone deeper there, and and they found this. It looks to me as though they found a second reef below the first one. The first one looks as though it's been eroded at the top, so you've got the two legs going down into the ground. And they've drilled through the top one and gone through lower down and found another one.
Okay.
So I'm hoping that they will go deeper and find another one. Because then it will be very similar to Telford. Could be a big open pit there.
Well, I'm pleased that I found all these drill holes because it's quite impressive when you look at it.
Yeah, there's loads, but if you go down further into Scallywag, there's a lot more historical drilling in Scallywag, but they haven't given us the results. I've got the results for those, just where they are, and mainly air core, which is shallow and stuff.
Yeah.
Could be anything 20 metres to 100 metres, but it won't be much more than that. But they may not have gone deep enough. Yeah, it's good. I enjoyed researching that. That was good. But that one is part of this. It's going.
It sits up
west-
here. It
northwest.
sits up here, doesn't it?
Yeah, it goes through a little bit in Antipas and then it comes out into that geological structure is on that top left.
No.
So it's probably a lot of gold in that top left corner.
Works for me.
Hopefully. So then we've got Oak River, which we've won, haven't we? Can you see Oak River?
Yep. Just here.
If you blow that up, see those little squares?
These ones.
Fortescue got the two top ones. I think Fortescue got that big one down there. No, not that one. That is Wishbones. That's what they were saying. Ah, we've won that against Greatland. So we lost that. But we've got Oak River. When you look on Wishbone's website, they've kindly given us the target on Oak River, or one of them. I can't remember if I've done that one. If you go on the next one. Oh yeah, that's from Wishbone's website. So you can see where Fortescue is. And that white rectangle is Wishbones. And we're looking for MB1. See that in the middle of... If we go to the next one. There you go. Gold
So there's
silver.
there's Wishbones.
Yeah.
We're over the ridge.
Yeah. They got a similar structure to that one. So if you go to the next, I think I've put it on. Can't remember. Yes, this is Wishbone's target. So that's their magnetic survey. So what they're saying is we've got one similar to that.
Okay.
So hopefully it's a big one.
Yeah, well, we know how to drill it. They don't.
Yeah.
We've also got the money to drill it. But let's not talk about them.
Right, next one. Don't want to lay on that one too long.
No. There she is.
This is one that a lot of people haven't seen. Thanks to Strudel. She's overlaid Ernest Giles on top of Stroud. I don't know if people know this area, but it's going from the bottom left, Trowbridge.
Down here.
All over Bristol. Newport, over the Severn Bridge and everything. Newport, over the top of the South Wales valleys, Abergavenny, follows the M50 up to Tewkesbury, and then it goes back down. On the right is Westwood. You've got Western East Westwood. That goes down to Swindon. So, I mean, that gives you the scale of what we're looking at.
I mean, in M5 travel terms, it's like 8 hours, isn't it, with all the traffic?
Yeah. Get through Britain. So we'll be looking, and this goes back to my earlier comment about greenstone, because this is all greenstone, Archean. It's older rocks than we got at Havron. Havron started at 600 million years ago, 630 million years ago. The cover sequence was from then. But this is older rocks, about 3.5 billion years old. But there are some sulfides. On the bottom, right at the bottom, is meadows. That's more than likely the place we're going to start drilling. We've had a couple of campaigns. But if he doesn't drill there first, I should be very amazed.
Isn't Meadows where we got the money for? Grant, that's the word.
Yeah, that one there. Yeah. That's where Newmont focused. Although Meadows goes. What you see here is the new licenses applied for, and those were 2 old licenses. But the application's gone in, and I think they're merging those 2 licenses, so the Meadows is going to be expanded.
Yeah, so when you look at it, there's actually an area they're not covering, and I've got a sneaky suspicion this is part of the native title.
Yeah.
To me, there's an area of significant interest for the native title people potentially. It's
Carnegie that we did have in the middle, like an island in the middle. We haven't got that. We've lost it, or haven't applied for it again. And we've also lost some of Empress. When you get back to it, I'll point it out.
So there's this area here.
Yeah, there is a tiny little bit, yeah.
And there's your meadows.
Yeah, that you can see the wildcat drilling that we've done in the past. And I think they had some failures. The ones at the bottom right are off the target. And I think it caused some confusion amongst people.
Okay.
In the early days, thinking they were duff drills, but they're wildcat drills, so they were finding the edges of that target. Now Newmont weren't doing this; they were doing to the northwest. Okay, so we possibly got a 5 million ounce.
Well, I mean, to quote the managing director, it's a ripper.
Probably is. But Newmont found a bigger target to the northwest. I mean, those targets are 3-4 kilometres long. So the weak gold, probably about 2 grams per ton, something like that. But they're over a large area. We've got a lot of drilling to do to tie that up. There is a track to the bottom, to the southeast of this, that runs from southwest to northeast. I don't know, probably won't pick this up, but so it's closest to the what little infrastructure there is. That must be it.
There you go.
It's going to be a dirt road, isn't it?
It's all ours. Might have to come along one night and plot all these little colours.
There is some infrastructure there, but not much. But it's more than what we've got at the top end of it. Because you imagine trying to get to the top end.
Yeah. Yeah, I mean, if they want to come and drill up here, they're going to have to basically build a road, aren't they?
Yeah, I mean, you can see how barren this is in this desert. And if anybody saw the pictures I've been putting up on the fire tower of the lookout looking over the hills and the forests, the outstanding beauty.
Yeah.
You can see why he wants to concentrate on this rather than fire tower. I think we'll have trouble with getting approvals. Although there are, it looks like there is a mine at Fire Tower West. Well, somebody scratched it, got it ready for mining. But Ernest Giles is so big, and it's greenstone belt. It's Archean greenstone belt. It's gold. There's little copper. There's a few bits. Now, I'll wait till you get back to the presentation bit. So we've lost Carnegie in the middle, which would be over the 7. That bit of blue.
Oh, over here.
Up a bit. Up to the right a bit. To the right, to the right, to the right. Yeah, take that way. Carnegie's in the middle.
Okay.
That's Westwood, where your pointer's gone. The top right is Empress. Now we've lost a great big long license to the north, and we've lost a long target to the south east of Empress. So if you go back to the I don't mean on slides, but MMI surveys. Okay, the MMI surveys in Meadows, I think the gold, the soil sampling was 68 parts per billion for gold. But at Empress, you're looking at 338 parts per billion gold. So Meadows isn't a strong gold as what Empress is. But it's near infrastructure, so if we're going to start somewhere, because it's such a massive license.
Yeah.
It's going to take some drilling.
It's almost like... Oh, sorry, rather than stretch. It's almost like building Telfer before you found Javier on.
Yeah. But this is 2/3 the size of the M25. So it's just a colossal license. It's just going to take some drilling.
Hmm.
So we've got Empress to the top right. We've got Westwood in the east. Where it says E38 in the top. That unfortunately is called Wishbone.
No relation.
No relation, but that is the MMI results were good on that. And then when you come south from Wishbone down is Dromedary. The MMI results were okay on that. And if you follow that red line down, right, that I think is called Maple. a little red dot in the top of Meadows. That is Wellstead Hill. And some of the results there are pretty good. And Newmont's find is between Wellstead Hill and Meadows. I don't criticise Newmont for walking. I think it was just a business decision. And what they've done is left us with some great survey information. So we make use of it.
Yeah.
And I think that's the end. Is that the last slide?
I don't know.
I think it is. Unless you've got anything else to pick up.
No, I'm that's me. So I shall do that, and then I shall go back to here. And that one, and that one. Haha. So, I mean, that was absolutely fantastic, Bamps. Thank you very much.
I'm glad you followed it.
No, I did, and it was really helpful to see the slides and visualize stuff. And anyone that's joined us recently, definitely go back to the start, because we really go into where the gold comes from originally. So thank you so much. It's been long overdue that we sat down and talked things through, and I'd love to, the next time you make a presentation, just meet again like this and get it out there, because it's fascinating.
Yeah, I do enjoy doing a presentation, even though I must have walked about 2 miles when I was prancing about in front of the screen.
Well, you've earned yourself a slice of cake or a cream tea for lunch. Okay, everybody. Well, I think that's us for the end of the presentation. I definitely need a new cup of tea. Bamps, thank you so much for your time this morning. I really, really do appreciate it. And everybody else, we will see you soon. We've got some results coming next month. We've got an AGM, and at some point we'll see a feasibility study. What do you reckon, Phil, with that one? February maybe, or later in the bit later in the year? When's your?
I think it'd be February.
I think it makes sense, doesn't it, personally? Okay, cool. Well, I'll let you get back on with your day. Everybody else, thank you very much. My name's Liam, and you've been watching Brew a Bottle on GGPHelp TV. And I don't know how to hang up this stream. So there we go. Thank you and good day. That